Mars has air. That's a fact. So here's the question that confuses almost everyone. If Mars has air, why can't we breathe there? Why can't an astronaut just take off their helmet and survive, even for a few seconds? This question sounds simple, but the answer is dark, surprising, and honestly unsettling. Because the truth is, Mars does have air, but that air is almost worse than having no air at all. When people imagine Mars, they often picture a thin atmosphere, but still an atmosphere. Clouds, wind, dust storms, movement, and that creates a dangerous illusion. We subconsciously think, if there's air, breathing should be possible. But breathing isn't just about air being present. It's about the right kind of air, the right pressure, and the right balance. Mars fails all three. Let's start with something you've never had to think about before. Oxygen is not just something you breathe. It's something your blood needs at a specific pressure. On Earth, oxygen makes up about 21% of the air. That balance is perfect for human lungs. But on Mars, oxygen makes up less than 1% of the atmosphere. The rest is mostly carbon dioxide. That means even if you could somehow breathe the air, there wouldn't be enough oxygen molecules entering your bloodstream to keep you alive. Now imagine this. You step onto Mars without a helmet. You take one breath. Your lungs pull in air, but your blood can't grab the oxygen it needs. Not because your lungs fail, but because the oxygen pressure is almost non-existent. Within seconds, your brain begins to shut down. Not from choking, but from oxygen starvation. You would lose consciousness in about 10 seconds. Death would follow shortly after. But that's not even the worst part. The pressure on Mars is less than 1% of Earth's atmospheric pressure. That's incredibly important. Pressure is what keeps gases dissolved in your blood. Without enough pressure, those gases come out of solution. That means the moisture in your lungs and body would begin to vaporize. Not explode like in movies, but enough to cause severe damage. Your body is literally not designed to exist in such a low-pressure environment. On Earth, water boils at 212 degrees Fahrenheit. On Mars, water can boil at much lower temperatures because of the low pressure. That means the moisture on your eyes, tongue, and lungs would start to evaporate. Your body would be fighting physics itself. And here's something most people don't realize. You wouldn't feel pain right away. You wouldn't have time to panic. You wouldn't scream. You'd simply collapse. Mars air isn't poisonous in the way we usually think. It's worse. It's useless. The carbon dioxide concentration on Mars is extremely high. On Earth, carbon dioxide makes up about 0.04% of the air. On Mars, it's over 95%. Breathing pure carbon dioxide doesn't just suffocate you. It causes your blood to become acidic. Your nervous system fails. Your heart rhythm becomes unstable. Even if oxygen were magically added, the environment would still be deadly. Now let's talk about wind. People see images of dust storms on Mars and assume the wind must be powerful. But here's the strange part. Mars winds can move fast, but because the air is so thin, they don't carry much force. A 60-mile-per-hour wind on Mars feels more like a light breeze on Earth. The air simply doesn't have the density to push against you. That thinness is exactly why breathing is impossible. Think of it this way. Mars air is like breathing at the top of Mount Everest, multiplied by several times. Even trained climbers can't survive long at extreme altitudes on Earth without oxygen. Mars is far worse than that. There is no comparison. Now let's go deeper. Mars didn't always look like this. Billions of years ago, Mars likely had a thicker atmosphere. It may have had liquid water on its surface, rivers, lakes, maybe even oceans. But Mars lost its magnetic field early in its history, and that changed everything. On Earth, our magnetic field protects us from the solar wind. It deflects charged particles coming from the sun. Mars doesn't have that protection. Over billions of years, the solar wind slowly stripped Mars of its atmosphere. Bit by bit, molecule by molecule, the air literally escaped into space. What's left today is a thin, fragile shell of gas barely clinging to the planet. Enough to create dust storms, enough to scatter sunlight, but nowhere near enough to support human life. And even if we could somehow add oxygen to Mars, breathing would still be impossible without increasing the pressure. Oxygen percentage alone isn't enough. You could have 100% oxygen, but if the pressure is too low, your body still can't use it properly. That's why astronauts use pressurized suits, not just for oxygen, but to keep their bodies functioning at all. This is where science fiction often misleads us. Movies show people walking on Mars with simple masks or thin suits. In reality, Mars requires full-body life support, pressure control, temperature regulation, radiation shielding. One failure, and the environment wins. And radiation is another silent killer. Mars' thin atmosphere offers almost no protection from cosmic radiation and solar radiation. On Earth, our thick atmosphere and magnetic field absorb and deflect most of it. On Mars, radiation reaches the surface almost unhindered. Breathing aside, long-term exposure damages DNA, increases cancer risk, and affects the brain. Even if you solve the breathing problem, radiation would still be killing you slowly. Some people ask, why not just build domes? Fill them with air. Create a mini-Earth on Mars. It sounds simple, but it's incredibly difficult. A pressurized dome on Mars would be under constant stress. The pressure inside would be much higher than outside, pushing outward all the time. Any crack, any weakness, and the air escapes violently. And then there's dust. Martian dust is fine, sharp, and electrostatic. It sticks to everything. It damages seals. It wears down materials. Over time, it would threaten the integrity of habitats and suits. Mars is not just passively dangerous. It actively erodes anything we bring there. So when you ask why we can't breathe on Mars, the real answer is that breathing is only one part of survival. Mars attacks the human body on multiple levels at once. Air composition, pressure, temperature, radiation, gravity. Gravity itself plays a role. Mars has about 38% of Earth's gravity. That affects how fluids move in your body, how your lungs expand, how your heart pumps blood. Over time, even breathing mechanics could change. There's also the psychological impact. Knowing that the air outside will kill you in seconds changes how you experience the world. Every step outside a habitat becomes a calculated risk. There's no casual existence on Mars. Every moment is managed. Some scientists talk about terraforming Mars, thickening the atmosphere, releasing trapped gases, warming the planet. But this would require energy on a planetary scale. And even if it were possible, it would take thousands of years, possibly longer. Mars is not waiting for us to fix it. Mars having air is actually misleading. It creates false hope. The truth is, Mars has just enough atmosphere to remind us what it lost. Enough to show us what a dead world looks like after it once had potential. And that's what makes Mars so important to study. It's a warning, a reminder of what can happen to a planet when it loses protection, when its systems fail. Mars is not just a destination. It's a lesson. So when people say, Mars has air, why can't we breathe? The real answer is this. Breathing isn't just about air existing. It's about balance, pressure, protection, stability. Mars has none of those. Mars doesn't just lack breathable air. It lacks forgiveness. And maybe that's the most important thing Mars teaches us. Earth is not normal. Earth is rare. The air we breathe without thinking is a miracle of balance that took billions of years to form. Mars shows us how fragile that balance really is. And once you understand that, you stop asking why we can't breathe on Mars. You start asking how lucky we are to breathe at all.